Okay, ladies and gentlemen, welcome to the first set of notes for the Euler Graph Theory lesson, unit of finite mathematics. Now, you have never done any graph theory before. This is an entirely novel concept. So on the board here, you see a famous mathematics problem called the Bridges of Konigsberg. Essentially, here's how this problem works. We have two banks, a north and a south bank, and two islands. This composes a city called Konigsberg in ancient Prussia. So you'll notice that there are a total of two bridges connecting the south bank to island A, two bridges that connect island A to the north bank, one bridge that connects the two islands, and one bridge that connects island B to each bank. Your task is to find a path starting on the south bank and crossing each bridge exactly one time, ending up back where you started. So what I'd like you to do at this point is please pause the video and attempt to find that path. You may not enter the water. That would be anything in there that is underneath the bridges. You may not cross a bridge twice, and you must start and end on the south bank. So please pause the video and try that problem now. Okay, now, that problem is not possible. And we have been able to prove mathematically in the last 100 or so years that in fact that is not possible. And the reason that that is not possible can be shown in a much simpler way by representing that problem as what is called a graph. So there on your screen, you will see the definition for the word graph. A graph is a picture consisting of dots, which we call vertices, that being the plural of the word vertex, that may or may not be connected by lines, which we call edges. So in this case, the vertices, which are L, A, R, and B, represent the land masses from the previous problem. L and R being the banks, A and B being the islands. And the edges connecting those dots represent the bridges. Leonhard Euler, who's a mathematician during the time of this problem, proved mathematically that it is not possible to start anywhere on this graph and end where you started. And we are going to go into this unit where we will discuss why that is true, why it is not possible to do that. So, first thing we need to do in this unit, and the point of our first set of video notes here, is we need to go through all of the associated vocabulary for this lesson. So we'll start with a different graph. We'll start with this graph here, which has 5 vertices labeled A through E. And we're going to discuss a couple of interesting things here. First of all, you'll notice that all vertices are named with capital letters. So when we name a vertex, we name it just like we did points in geometry with a capital letter. The edges will be named using the starting and ending points of the edge. So for instance, this edge right here, that is edge BC or CB. It doesn't matter. Okay? So some points of interest. First of all, you'll notice that there is no point indicated here where these two edges cross. That is because this is not an intersection. The way I always try to explain this is that that is more like an overpass, meaning that you cannot switch roads there. One goes over the other. So because of that, we need to make sure we understand that edges can cross each other without actually crossing each other. If there is no vertex indicated, there is no vertex there. Secondly, you'll notice a pair of edges at C and CD that both start at C and end at D. Those edges, in this case those would be edges CD, is what's called a set of multiple edges, because there are more than one edge that we could name CD. There are in fact two here. So if I ask you to identify a set of multiple edges, that's what I'm talking about, a set of edges that connects more than, or connects two vertices more than one time. So there we have two different edges that we could name CD. That would make CD a set of multiple edges. One more slide, and then we'll pause this first video and go to the second. This one has a lot of vocabulary on it, so we'll just start at the beginning. Up here on the left, you'll see a graph. In that graph, you'll notice that there is an edge that starts and ends at G. That edge, GG, is known as a loop. That is what we call a loop. A loop is an edge which starts and ends at the same vertex. It is the only loop in this graph. So in order to have a loop, you have to have an edge that starts and ends at the same vertex. You notice that edge starts at G and ends at G. Next up, this graph is a graph that we would call connected. What that means is that it is possible to travel along adjacent edges from any point on the vertex, any vertex on the graph, to any other vertex on the graph. So if I wanted to get from C to E, that is possible without picking up my pen. If I want to get from G to D, that is possible without picking up my pen. I can get from any point to any other point in the graph without having to jump, without having to pick up my pencil. Okay, next up, edge AH is called a bridge. A bridge is an edge whose removal would cause the graph to become disconnected. Okay, there are a total of two bridges in this particular graph. The other bridge is EF. Notice that if I remove edge AH from the graph, I now have two separate pieces to that graph. I have A, B, C, and D up here, and I have E, F, G, and H down here, and they are not connected to each other. The same thing could be said if I removed edge EF instead. That disconnects vertex E from the rest of the graph, making EF a bridge. A bridge, again, is an edge whose removal causes a graph to become disconnected. We'll stop there for the first video. There's going to be at least one, maybe two more videos to this lesson. So please make sure that you watch this again if there's any vocabulary you're not 100% clear on. Thank you for your time.